Hello, Math 1. This is the last lesson of remote learning spring 2020. Whew. Okay. It's a little anticlimactic, though, because I'm not teaching any new material. I'm literally going to go through the odds homework assignments on this document you see behind me. It's literally reviewing the last 3 lessons we've had, so you're really not seeing anything new, but it is a good thing to practice the things that I think are fundamental for having some success in your next math class. So let's get to it. Our first one says factor each polynomial completely. And I put in here, do not solve the equation. There's no equal sign. Because I see a lot of students who, they start to get into that mode of not really thinking. They just go on autopilot and they're like, oh yeah, I remember AC method. They'll do the factoring, but then they'll try to solve this phantom equation in which there is no equation. It's just a polynomial in which I'm asking you to factor. So here's what it means if it says factor, not solve the equation. So the first thing we ask ourselves is it in a position to be factored? Like, is there a GCF that we can take out? I'm looking at 9, negative 15, and negative 36. They all divide 3. So what I'm going to do is say, take out the GCF of 3. The leftovers would be all these parts divided by 3, giving you 3x squared minus 5x minus 12. Now we've got a trinomial inside parentheses here. We're going to use that trinomial. We're going to use the AC method on that trinomial. So remember, the task is, you've got 3 times negative 12. That's negative 36. What factors of negative 36 add up to the middle term of negative 5? So you can go through the entire list of negative 36 factors. Negative 1 in 36, 1 in negative 36, 2 in negative 18, and so on and so forth. If you can spot it right away, though, if you're like, hey, 9 times 4, in which one of them's negative, negative 9 and 4, hey, that adds up to negative 5. Those are the factors that I want. Just go for it right away. There's no need to list all the other factors. So what we're going to do now is say this negative 5x is going to be replaced with negative 9x and a positive 4x. Okay? And I'm intentionally grouping the negative 9x with the 3x squared because I can see they share something right away. So 3x squared minus 9x plus 4x minus 12. These two grouped together, they both share a 3x. And then I'm going to divide each part by 3x to get the x minus 3 leftovers. Okay? Then this, we see, shares a positive 4. Dividing both parts by 4 gives us x minus 3 again. And remember, you are supposed to get identical twin leftovers because that's the way in which distribution works the opposite way. These come together. The two GCFs are the two things I'm pointing to here. 3x plus 4, okay, times x minus 3. That's the final reverse factoring move. And then don't forget about that 3 you factored out at the very beginning. It's going to come into play with the final factored polynomial. And that's it. Let's check out number 3. All right, this one's slightly different. We've got x's, y's, and xy terms. I'll write this a little bit larger for you guys so you can see it better. I mentioned this on a previous video. Whenever you have multiple variables in which you can't factor a GCF out, specifically ones in which there's squares here, you need to recognize that, hey, whatever the middle term is, it needs to share with both the first term and the last term. So it makes a whole lot more sense to flip these around before we do any type of trinomial factoring. So I'm going to say x squared minus, and I'm going to put a 1 in front of the xy. 1xy minus 56y squared. This sets it up perfectly for us so that we split our xy term into two xy's, making sure that the x squared is going to share with the xy, and the y squared is going to share with the xy. Okay? So now we're kind of thinking, all right, if these y's really didn't exist and we just had that going on for us, we could figure out that, hey, what multiplies to give me negative 56 and adds up to give me negative 1? So what multiplies to give me 1 times negative 56 and adds up to give me negative 1? Again, you guys can put together this whole list of the factors, but if you can see it right away, 8 times 7, that's 56. And in this particular case, you need one of them to be negative. Negative 8 times positive 7 is negative 56 multiplied and adds up to negative 1. So we got it. Those are my two factors. Now here's the important piece. They both must have an xy. So this is negative 8xy for the negative 8. This is positive 7xy for the positive 7. Once we get to here, we factor by grouping. This one's pretty basic. X is what they share. That's what I'm taking out. Take an x away from x squared, you get x. Take an x away from 8xy, you get minus 8y. These two, 56 divides 7, we just saw that right there. And they both have a y, so take out a 7y. I'm taking out a positive 7 because I don't want the sign to change. I want a plus x minus 8y. I've got a plus here and a minus. I don't want to take out a negative to switch that around. So when we divide this out, x is left over. 56 over 7 is 8. One of the y's remain. And we got identical twins like we need. So then these come together to be x plus 7y times x minus 8y. Let's check out 5. All right, the directions just changed. It says solve each equation by factoring. So basically what we need to do is replicate the situations we had in the previous two examples. What I mean by that is we need to get trinomial factoring on one side of the equation. So right now, we're looking at that 72 on the right, and we're thinking, let's get 0 by itself, because we can use that thing called the zero product property. If you don't know what I'm talking about, then you probably didn't watch my last video. Go watch my last video. Okay. So subtract 72 from both sides. You get x squared plus 71x minus 72 equals 0. Great. Now what we do is we factor the left-hand side. So really before the AC method, we should be thinking to ourselves, is there a GCF that can be factored? Is it in standard form? It is in standard form. There's no greatest common factor to take out of it. So we take 1 times negative 72 to get the AC. And we look at our middle term to get the B value. Now I'm highlighting this particular example because a lot of students, they oftentimes forget that the most obvious factor for some of them is that number and itself. So, I'm sorry, not 1 and the factor, okay? Sorry, I kind of butchered that. Let me just show you what I mean. 72 times negative 1 is negative 72. Add them together, you get positive 71. So sometimes that just escapes people, like, oh, I didn't even think to make that my middle term split up into 2. All right, so that's the ticket. We're going to take the middle term, divide it into, you know what, I'm going to flip these around. I'm going to say that this is negative 1x, and this is going to be positive 72x. Because I don't know, the 72 here just kind of jumps out at me. So, the middle splits up into those two. And then reunited with the other parts of the polynomial gives you this 4-term business. They group together to give you x. They group together to give you 72. If you divide, you're going to get x minus 1 for the leftovers. Now, this is x plus 72. The GCFs go in one group. X minus 1 are the leftover groups that combine to 1 equals 0. This is the part where I was talking about the zero product property. Okay? So the zero product property. If I've got x plus 72 times x minus 1 equals 0, that means that one of these must be 0. Either x plus 72 equals 0, or x minus 1 equals 0. That's your basic zero product property. You can't multiply, get 0, and not have one of these two be 0. 0 is not obtained through multiplication unless you multiply by 0. The nifty thing about that is it creates pretty simple equations to solve. And then you're left with x equals negative 72 and x equals positive 1. And those are your two answers. All right. You know what? I think I'm going to stop the video, start it over again, and just do the last 3 odds on a separate video. Okay?